Okay, guys, we're going to be starting off this workshop, and it's my absolute pleasure to moderate and to introduce our amazing panelists. In case you forgot what you signed up for, this is a free web workshop provided by Performance Nutrition Pros entitled Do You Know How to Evaluate and Use Probiotics in Your Practice? And if you've been following Performance Nutrition Pros in the last few years, we do these Do You Know How To free web workshops, and we've done quite a few over the last couple of years. So if you want to visit our website to see some of the previous recordings, what we try to do is take kind of a big area of practice and kind of break down the science and break down the applied aspect of that. And so I'll introduce our panelists here. First, Dr. Dana Liss. She's a registered dietitian and she's a co-founder of Performance Nutrition Pros with myself. She's also a research affiliate at the University of California, Davis, and in her 6th season as the lead consulting dietitian for the Golden State Warriors. Dana completed her bachelor's degree and dietetic internship at University of British Columbia in Canada. She's also a graduate of the prestigious IOC diploma in sport nutrition. And her PhD was completed at University of Tasmania, that's in Australia. And her research was actually in exercise gastroenterology, specifically the athlete's gut. And she led a lot of the development of kind of FODMAP strategies in managing exercise-induced gastrointestinal syndrome. Her postdoctoral studies were completed at UC Davis with Dr. Keith Barr, focusing on nutritional interventions to enhance collagen synthesis. And in her 17 years as a practitioner, Dr. Liss has worked across the MLS, the NBA, USA Cycling, European World Tour Pro Cycling, and a bunch of Canadian national teams. And as a researcher, she has published 14 scientific publications, and she continues to collaborate within the international sport nutrition community and continues to lead research in the field. And then Kara Seidman is did I say that right? Seidman?
Sorry, I couldn't find my Seidman, close.
Seidman, okay. Kara Seidman, sorry, I knew I was going to get it wrong, is a registered dietitian and senior manager of scientific communications at Pendulum. And her bachelor's degree is in nutrition and dietetics from University of Massachusetts, Amherst. And she completed her dietetic internship at Cal Poly San Luis Obispo. She's got a background in diverse healthcare settings and specializes in integrating functional and integrative approaches in gastroenterology and metabolic health. And then before joining Pendulum, Kara worked in the microbiome field, sharing research with healthcare practitioners and guiding the clinical use of bacterial strains and microbiome therapies. And she's really driven by her passion for translating complex research into practical healthcare solutions. And that's why we're so excited to have you, because collaborating with you and Pendulum for this webinar has just been exactly what our mantra is at Performance Nutrition Pros, which is lab to life. So bringing that translational complex research into our applied settings. If you just wanted to flip the slide, Dina. And then I also just wanted to mention that this lecture today is actually a lecture module within our new online course that we're actually going live with today. It's called the Athlete's Gut Advanced Practice Course. Dr. Dana Liss, myself, have collaborated with Dr. Ricardo Costa and Dr. Stephanie Gaskill at Monash University to come up with a on-demand, self-paced athlete gut course. So basically, what we realize is that there's a huge gap of learning in exercise gastroenterology with nutrition practitioners. So we go through school and maybe we get some information on digestion and physiology of digestion, but working in sport, we really don't have any formal training in the area of gastroenterology. So that will be launching live today. We hope you check it out. And this module actually fits in as our bonus lecture within it. There's seven modules of learning, and we're excited to actually launch our course in partnership with this web workshop. So we'll just scroll ahead there.
No problem.
Yeah.
All right.
So I'll go quickly through an outline of the web workshop today, and then Dana will kick us off. So we'll go through an introduction and kind of just define what the microbiome is, just so that we're all on the same page. And talk a little bit about the athlete microbiome and why is this becoming an area of increasing interest in both the practice and research field?
Sorry.
That's okay. And so Dana will kind of cover the research area in terms of the athlete space and what's going on in our domain. And then Kara will jump in and talk a little bit about how we need to kind of be more educated around not just a blanket probiotic for everybody, like, and I think that's something that a lot of practitioners do. We just, hey, everybody, just take a probiotic, broad spectrum, we're good. But we're kind of getting deeper in the knowledge of strain specificity, capsule technology, and kind of the next level practice when dealing with athlete gut situations, and then also prescription and dispensing of product. And so Carol will walk us through that. We'll do a Q&A, as I mentioned, Q&A questions. If you can put them in the Q&A section, that would be great. And we'll just sum up with what we're doing in the athlete gut space again. So I'll let Dana take it away, and I'm just gonna mute my line and video.
Perfect. Thanks for the great intro, Jen. So before we get started, part of what we're doing with performance nutrition professionals is trying to find those gaps in practice where there's not really like a clear pathway for how do I really get more kind of world-class knowledge in this area. So we're, even from the first Elite Ops course that we hosted, there was a ton of interest and questions and kind of gaps around the athlete gut space. So I'd say, yeah, hands up. I historically have been like, yeah, hey, here's an NSF certified multi-strain probiotic. I can't read most of those words, but hey, I think that's what we need. So we're going to put that in our, our daily pack or whatever. And, over the past few years and since I started working in exercise gastroenterology and understanding more about the athlete's gut, that the research and the knowledge in this space has evolved quite a bit. And, as practitioners, we continue to evolve our practice. And part of that is a little bit of just, kind of self-reflection and check-ins. And some of the questions I encourage you to ask yourself are like, one, do you prescribe probiotics to athletes? What do you prescribe? There's no right or wrong here. It's just, evolving your knowledge and practice. So I definitely don't want anyone to think like, oh crap, I'm still doing that, or there's nothing wrong with that. It's just about gaining knowledge as you grow as a practitioner. Next sort of self-reflection or practice reflection to, what products or strains do you prescribe? How do you assess the viability and efficacy of a probiotic product or specific strain? And what would improve your confidence in managing the athlete gut health area? So just some, kind of reflection questions for yourself as a practitioner as we go through these two sections. So quick little bringing everyone on the same page. There's microbiomes actually all over the world. Microbiomes are a community of microorganisms, fungi, bacteria, viruses. In the gut microbiome, that's in your gut. And when I told my son that actually you have bugs living on your skin, he was like, oh, he's 10, so he'll be like, brother, ew. He has all these hilarious like kid things that I'm too old to know. But the gut microbiome is obviously what we're talking about, but there are microbiomes everywhere, from if you learn about ecology to gut microbiomes on your skin. The gut microbiome in your GI tract is constantly changing. So, in athletes, there are a range of factors that influence this ever-changing gut microbiome. And we're learning more and more about how all of these different factors affect your gut microbiome health, essentially, and how some factors in your gut microbiome actually can directly impact performance parameters. So probiotics, are probably what we hear about first. And Kara's going to go a little bit more into like prebiotics and synbiotics. But probiotics are, live microorganisms. They're in food, they're in supplements. If you've ever made kombucha, your little SCOBY guy there, everything you're seeing there is actually organisms fermenting. They're doing metabolic things. And the probiotics that we have in our gut are live microorganisms. We can get them from food, we can get them from supplements. And, ideally we have a profile that's beneficial for our gut. It's kind of in balance, and there are, it is a complex area. And even from a dietetic perspective, where we're just, kind of taking that space of probiotics and figuring out, okay, where do we get probiotics in food? If I'm working with an athlete and we're going through, their nutritional strategies, where do they get probiotics from food? Well, they'll be like, oh, I eat yogurt and I drink kombucha, so I'm pretty good for probiotics. And then you might say, well, actually, when something's fermented, when something's pasteurized, what does that do? It actually kind of brings down the level of the amount and the population of the probiotics in the foods. It kind of kills a lot of them. You'll still get some probiotics, but it might not be enough to modulate any gut changes. And that's something that Kara is going to dive into a little bit. So I'm not saying there's no probiotics, but I'm saying if you want to maintain, you'll get some probiotics from these foods. But if you're actually looking to change things, we're going to need to look at some different strategies and options. And then, of course, there's supplements, tablets, there's chewables, there's gummies. There seems to be probiotics in like canned fizzy waters now. How many of those are actually viable? Probably very few. But our goal today is to help practitioners really understand how to assess product viability, essentially. So what you're recommending to your athletes is something that is actually live. So a few terms here that we'll go through, and Kara's going to add a few more. Commensal bacteria are bacteria that live symbiotically with the host, so they're kind of your friendly bacteria. Short chain fatty acids, they're fermented by bacteria, and they're kind of under 6 carbon chain lengths. We know that short chain fatty acids basically are good. We want those, and they're important for maintaining epithelial integrity, so your gut health. They're an energy source for colonic cells, and they help regulate immune responses and inflammation, metabolic health. The term exercise-induced gastrointestinal syndrome. So you'll also hear us use the word eggs, which don't get confused with chicken eggs. So exercise-induced gastrointestinal syndrome. If you continue this webinar and you go into the Athlete Gut Advanced Practice course, eggs will be part of your common knowledge, and you will know what you're referring to. But eggs refers to the disturbance of gastrointestinal integrity and function that's common with strenuous exercise or kind of long endurance exercise. Alpha diversity and beta diversity. So, alpha diversity is kind of the richness and evenness of all the different microbial species. And the beta diversity is like the different microbial communities between different samples. So if you're looking at research that has an intervention group and a placebo group, that would be your sort of beta diversity as an example in some of the more recent athlete studies with probiotic supplementation. So as I mentioned, there are a ton of factors that affect your microbiota composition, and it's constantly changing, day to day, week to week, and even in the FODMAP space, even 1 to 4 weeks, we can measure changes in certain probiotic or microbiota species in a short time frame like that. So we know that everything from geographical location to mode of birth delivery to your age to stress to sleep to genetics to diet, there are so many factors that affect the general person's gut microbiota composition. And then in our world, there are a whole host of factors that also affect the athlete's gut microbiota composition. I didn't mean to animate that. That just happened. So even with athletes, there are more factors. So we know that moderate intensity exercise is actually really good for your gut. It improves your diversity, kind of is an ideal world for a healthy gut microbiome. And, that moderate exercise is like, light cycling, jogging, running. How many of us are working in a world where our athletes are doing moderate exercise? When you work in sport, you end up doing moderate exercise and a lot less because you're working a lot. But all of the athletes we work with are on the other end of the spectrum, where they're doing intense, excessive, what would be classified as excessive, exercise with a lot of times suboptimal recovery. That's part of the stimulus, that's part of the adaptation. That's, you know, part of what we do with load management, but there is this sort of piece where you're overreaching and then recovering. But with suboptimal recovery and or nutrition kind of not being optimal in the immediate post-exercise period, that's when there's, you know, temporary disruptions in the gut microbiome environment. But one question I have, and this is sort of like kind of for you guys to reflect on, is okay, if you have your athletes, think about your athletes' training schedule, whether it's football, American football, or or UK football, whether it's you know, road cycling, gravel racing, pickleball. Think about the training schedule. Think about what the coach writes out on whether you use Training Peaks or an Excel sheet. How regular is your athlete? How often is your athlete training hard, or let's say, you know, longer, over hour and a half-ish? Pretty much almost every day, lots of back-to-back sessions, lots of 2-a-day sessions that would classify as, you know, intense or strenuous. And we know that it takes about 3 to 5 days for epithelial gut cells to turn over. So are our athletes kind of operating in a state of variable gut injury, variable epithelial kind of permeability? And that's what kind of led, you know, the original question around what I looked at for my PhD work. From a practitioner perspective, just understanding that, okay, this is kind of the gut environment that my athlete could be in. What can I do from a nutritional perspective to really optimize gut health? So even more factors affected with that athletes are faced with in terms of managing their gut health. One is with intense and strenuous exercise. We know that this splanchnic hyperperfusion happens. So where blood flow is shunted away from the organs of the splanchnic area, so your stomach, your lower intestine, upper intestine, to your muscles, to your working muscles. That always happens with, you know, more strenuous, longer exercise. But with this reduced blood flow to the gut, what happens is you actually get kind of, you're not getting oxygen, nutrients to that gut barrier. So the, you know, the proteins that hold, you know, that gut barrier nice and tight, they start not getting what they need to work. So they start breaking. And then you get translocation of things that should stay inside that your intestinal tube, essentially, inside your epithelial barrier, translocating across, getting either a local, you know, stimulating either a local or systemic inflammatory reaction. And we know that, you know, with this kind of chronically happening, could that be contributing to kind of greater inflammation in an athlete's body? There's so much context around that. There's no answer directly, but our goal here is to figure out what can we do to reduce kind of this damage, reduce the symptoms. And also realizing that athletes actually adapt. Their gut adapts, or your gut adapts, just the same as your muscles do. The first time you do a training session, it takes you a while. You're sore. It's hard. You do that session more times, it gets easier. You're adapting. Your gut adapts the same way. So it's not like every time an athlete does a strenuous session, they're going to have all this, you know, kind of gut permeability and inflammation. There's a lot of adaptation going on. But just understanding that this whole athlete space, alongside the splanchnic hyperperfusion and the sort of pathophysiology of eggs, we're also, you know, getting lots of travel, sleep changes, stress, either physiological or kind of psychological stress. There's circadian rhythm changes. There's factors like, you know, what do sport foods look like? A lot of sports foods are considered ultra-processed foods. What does that do to the gut microbiota? So just considering all of the factors aside from the normal kind of population, the general population factors, and then our athlete factors as well, that we need to understand that affect gut health. And then as nutrition practitioners, what are the things we can do to help maintain or optimize gut health? So splanchnic hyperperfusion, we've kind of gone through. We'll go through this in a ton more detail in the athlete gut course. So in a lot of detail. So if this is an area you're interested in, I'm really I think it's fascinating. But we'll go through that detail in the course. Now with probiotics, we have products that are multi-strain probiotics. They'll have 10 strains, billion CFUs. We might have a product that is a single strain and, have 1 million bacterial units or CFUs. And, and Kara's going to definitely talk to, what do you want to look for in a product? But so, we have these products, and then as, working in Olympic or professional sport, we're like, hey, we need to get something that's NSF certified. Okay, that checks the box. So there's the product of probiotics in terms of multi-strain or single strain. Why are we using these? And then when we have these probiotic products, we think they're going into this nice tranquil jungle environment of our gut where, yep, it just goes through and does its job, and then it gets through the stomach and, gets into the lower intestine and the colon and, does what it's supposed to do. But in reality, the jungle is not this tranquil thing. It's this like cutthroat changing environment that we can't necessarily predict. And we don't always know that, the acidity of the gut, that certain strains are going to survive the acidity of the gut, or certain products that we're buying off the shelf or in the fridge are going to survive the acidity of the gut. So just understanding that the gut environment is not necessarily this beautiful jungle, but it's actually kind of this chaotic, cutthroat environment that we're trying to understand. So why do we recommend probiotics to athletes? There are, several performance factors that, are important to most sports. And the main reasons why, practitioners, why are we recommending probiotics to athletes? What are the actions? What are the outcomes or mechanisms we're trying to address? Probably where the bulk of the research is in respiratory health or, immune system functions. So, and those are they're kind of linked with immune system function and reduction of URTIs or upper respiratory colds, essentially. Nutrient absorption. There's some evidence looking at lactate metabolism and body composition. And then there's the whole gut brain access piece where we know and we're understanding more about how certain microbiota profiles and certain strains and having certain, a population of certain strains are linked to different cognitive outcomes. And I'll go through a little bit of that. I'm not going to deep dive into every aspect of this, or we'd be here for the next probably 10 hours. But these are sort of the main reasons why, as sport nutrition practitioners, we are using probiotics, whether it's from food or strain-specific supplements. These are the main reasons, main 5 reasons why we're using probiotics. There is emerging research in trying to understand, inflammatory processes. There's some rodent research looking at bone health and skeletal muscle, and a lot more about understanding kind of antioxidant capacity and the inflammatory process. So this is definitely an area where there is a ton of research emerging. If you get into, some of the methodology of some of the research, yeah, I just definitely don't take, the abstract for verbatim. There's a lot of, methodological issues and challenges with, even the products used in studies. So we'll talk a little bit about that at the end. But the first thing, respiratory illness. As nutritionists, we're one of the first people that are called on to, first of all, develop our nutrition protocols for reducing risk of illness. And what are our protocols for if an athlete gets sick? What are we doing? Or what are we doing to make sure that certain periods when we know there's higher risk of illness, what are our nutrition protocols and our sort of nutritional physiology protocols? And there are, several studies, and I'd say this is probably the area where there's the most amount of evidence with specific strains or multi-strain probiotics, where symptom severity of upper respiratory illness is shown to help reduce symptom severity and illness duration. So the mechanisms have to do with inflammation. Usually in studies, cytokines will be measured and showing that, with intervention studied, less inflammatory response measured in some of the inflammatory cytokines. So the one thing about this area is there's a few different strains that seem to have this this effect? Do they work together? Do they work alone? Are there factors such as vitamin C that actually help modulate some of these strains inside in the gut? So it's never like a X to Y equals Z. There are a lot of different factors working together. With the immune modulation, I mentioned sort of, there's a higher rate of production of anti-inflammatory cytokines. So we're seeing more of a immune cell and the sort of anti-inflammatory immune cell sort of integration and stimulation or levels, depending on how the study has measured it. We're also seeing in some of these studies, they're measuring epithelial barrier injury or function. And we know that the epithelial barrier is important for preventing pathogens from crossing in over the sort of that barrier. So in some of these immune modulating studies, showing that, first of all, our gut is our biggest immune barrier. And we want to keep that barrier really healthy, really strong. If certain strains of probiotics and certain nutrition strategies are promoting this, what are those and how do we integrate those into our overall strategies? And that's, when we're looking at certain strain specific research. And what I encourage you to look at here is, ask yourself, which athletes may benefit from, digging into strain specific research or multi-strain specific research. Which athletes am I working with? And I'm like, oh my gosh, they're always getting sick, or they travel a ton, or this is a period of high travel where they're flying back and forth to Europe 6 times in 6 weeks. And when do I want to really make sure that we're doing everything to keep the biggest immune barrier in the body as strong as it possibly can? Yes, there's like we tell athletes, keep your nose moist on the airplane, put some Vaseline on it, put some chapstick on your lips, sanitize your hands. That's your first immune barrier. But once pathogens get in, your biggest immune barrier a lot of the time is your gut. So thinking about your yearly training plan or your YTP, where would some of these strains, where would it make sense to really target some of these strains into your, immune protocols or your kind of immune focus of your YTP? And the challenge we have as practitioners is in working in elite sport is that certification piece where we know that, this specific strain from this company has been tested in this study and it showed results that we want to kind of use in practice, but we don't have that third-party certification. So that's, that's another conversation for another time. There are some ways to kind of consider this, or, if you have the funding, do your own third-party testing on a batch, but conversation for another time. But that is a real practice barrier, and I recognize that. It's nice to say to do these things, but when there's a barrier like that, finding ways to solve that problem. So the next piece we looked at was nutrient absorption, iron. Raise your hand. I can't see you, but raise your hand if you're like dealing with athletes historically or now they're trying to get iron levels up, or you're trying to optimize iron levels, or you have athletes going to altitude camps and you want to make sure that leading up their iron is optimal and throughout we're really optimizing iron absorption and availability. And this is and there's only a few studies in this area, but this is just an example of a strain, Lactobacillus plantarum 299V. Sounds like a Star Wars droid, but where there have been 2 studies, and I mean there's always studies that show benefit and studies that don't. The one study that is on the side of this slide was showing the increase in absorption of iron from a juice, with and without supplementation, and then with a higher supplementation amount, so higher CFU versus a lower CFU. And in this study, it showed that with the probiotic supplementation, with the LP299B supplementation over time with the fruit juice, iron absorption was increased. The bioavailability was increased by about 50% from this study. Now, I think it's important to really look into the methods, and I try not to throw around like hard numbers like that because there's difference with statistics, etc. But knowing that there are microbes in your gut that play a role in how well you absorb iron. And that's a major factor in sport. When I first started looking at this research, I was like, where do I, I messaged a couple of the pendulum RDs and I was like, where do I find the most bioavailable LP 299B? Because I was like, I have trouble with iron. A lot of female athletes do. And yeah, I started chugging those capsules like nobody's business. But the mechanism that we're looking at is that this strain plays a role in lowering gut pH, which increases your iron solubility and possibly helping with the intestinal cells being more efficient in iron uptake. So if you look at some of your foods too, you might see this strain in some of your foods. It's commonly added to foods in certain countries, whether or not it's still really viable by the time you get that food. Something that Kara will cover. But just to know that like there are important roles that these these different strains play with with absorption of certain nutrients. And if you're having an issue with an athlete, yes, we can get an infusion in a lot of cases. But we want to hit kind of all the non-infusion options first. So in your athlete population, if you have, just if you have considerations with problems with iron stores or iron deficient anemia, how might you consider gut health as a factor in improving gut iron absorption or the microbiota? And what else do you need to consider and learn? And the other factor there with like kind of considering and learning is that, well, too much iron can actually have a pro-inflammatory effect. So if we're just like, take more iron and you'll absorb more, that kind of, it actually has a little bit of a opposite effect downstream in your intestines where it can have a pro-inflammatory response. So just really understanding all of the factors before you dive into adding new interventions onto your strategies. So other nutrients, and there are many more, but these are just a few I picked out because these tend to be something we deal with more as practitioners. One, folic acid. So and the one thing that I do recognize from a practitioner perspective is we see these studies and we see these strains, and then with these different strains, there are different letters attached and sometimes different companies attached. So in that, when that becomes kind of a barrier for you, just understanding, I'll go to like Pendulum's RDs and I'll go to sort of different industry experts and industry researchers to try to break down some of the strains that I see in studies because I don't fully understand, when I see different strains with a company attached to it. It's a strain that they've produced. So how important is that to efficacy? So I'll often go to different, industry experts to really understand that better. But anyways, aside from that, we know that there are certain strains that can improve folic acid, your folic acid synthesis endogenously, so inside your body, and secretion. So if you have somebody who's struggling with like their folate levels, the microbiome plays a role, and you're supplementing externally or exogenously, but endogenous production could help as well. Lactose intolerance, something that kind of sometimes happens with age, different genetics. We know that there are several strains, Lactobacillus rhamnosus, acidophilus. We know that some of these microbes and strains play a role and have a beneficial effect with reducing symptoms to lactose. D3, there's a really cool study with MMA athletes, some mixed martial arts, where they did a probiotic supplementation and a vitamin D supplementation together. And I mean, all the references are here. So if you want to dig into this, you can find out exactly what strains and what was used in these studies. This was a multi-strain. I think there was 3 or 4 different strains in this product, but they found that with the intervention being the vitamin D supplement, D3 supplementation with the probiotic had their vitamin D levels, blood levels of 25 OHD is what they're measuring, were higher with the intervention group. So with the probiotic multi-strain and the vitamin D supplementation together showed a quicker return to sort of normal and optimal levels of vitamin D in this mixed martial arts group. And then from the flip side, not just giving probiotics or focusing on a specific strain, but how do micronutrients affect your gut microbiome? And there, we know that vitamin C supplementation, and there are quite a few studies now that have looked at vitamin C supplementation having a beneficial effect on one, short chain fatty acid production, and then kind of upstream of that, bifidobacterium. We know that bifido is like kind of the number one we look at. And then there's some ratios of strains we look at that we know are beneficial for body composition or optimizing food energy extraction. And so the ratio being lower has been shown to sort of reduce your food energy extraction and associated with leaner individuals. So it's just one study, but it's interesting to even understand how not just the existence of these strains, not just the amount of these microbes in your gut, but the ratios also play a role in body composition, possibly. And then there is our gut-brain axis, and I will not get into this at all in any amount of massive detail, but we know, like, when you get a gut feeling, when you're nervous, why do you feel in your gut? There is a really cool connection between our gut and our brain. And there are a plethora of studies looking at depression scores, mood, anxiety, depression, ADD, ADHD, cognitive processing, sleep, all of these like various sort of what we think of as brain things as actually being gut brain issues, places where we can solve things. So even though sometimes you may be working with an interdisciplinary team and you have an athlete that's, struggling with depression or anxiety, and they go off to work with the psychologist and the sports psych, but recognizing that there could be a role for you as a nutrition practitioner to optimize gut health, but then also looking at strain specific ways that you can help that athlete, and understanding, okay, what do I need to do to measure? How do I see if they have the optimal, any sort of dysbiosis, or if I could help gut health overall, and then looking at strain specificity. So this is definitely like probably the most complex area of the gut microbiome, in my opinion. But we have a role here as nutrition practitioners, and to recognize that you don't have to know everything right away to be able to work with an interdisciplinary team, but recognizing that there is a nutrition role here with even, depression, anxiety.
Just a time check, Dana.
Yeah, I think 2 more slides and I'm good to go. I'll
Okay.
pass it off. Thank you. And then those performance factors. So there are several studies now that have looked at different strains and multi-strain probiotic supplementation or interventions in different kind of performance measures. And I would say we're still like really in its infancy with this area, but we have to pull from clinical research and pull from kind of understanding mechanisms. So we know that certain probiotics metabolize lactate. So if we have these strains and in our gut, if they're in higher amounts, will they help metabolize lactate better? So there's a rugby union study, and if you haven't read this study, it's worth reading. And the reference is at the bottom if you can see it. But they looked at muscle soreness and sleep and found benefit with this intervention. There are couple more studies that have looked at lactate metabolizing bacteria, and found indirectly beneficial effects in like recovery. And so this is just sort of an area where we're looking at what these microbes do, and then measuring outcomes over here, and then trying to figure out the pathway between. And then badminton, there's some interesting studies. And I look at the study because excuse me, I looked at the study and I was like 5.9% increase in aerobic capacity. So even if you see a study and you're like, oh, that looks like it really, really works, how often do you see a 5.9% increase in performance or performance metrics? Rarely. So I do encourage like looking at some of those numbers with your scientific skepticism in there. So there are direct effects. We're learning about this area. It's emerging. Definitely something to keep, there are a couple reviews written, not written in the best journals. So just keeping that in mind. But it is an area that more and more research and interest is investing in. So finishing it up, one of the areas that as practitioners we deal with a lot is injury, return to play, and antibiotics. And this is a question I'm going to leave you with, is what do you recommend to an athlete when they have to go on an antibiotic run or a couple antibiotic runs, or they've gone to Latin America and gotten some GI issues, had to go on antibiotics. What do you recommend? What's part of your systems and protocols? And I don't need you to answer this right now, but as we go through, Kara's section and learn more about strain specificity, et cetera, hopefully you might have like a better idea of how you would support an athlete that's gone on a probiotic run to make sure that, they come back with a, sort of optimized gut microbiota given the situation. Key takeaways: there is no standard cookie cutter probiotic protocol for sport. I wish there was, but there's not yet. We have to use a really targeted and rational probiotics and strain selection and use. There's a holistic approach here with the whole athlete gut. Probiotic supplement or probiotic foods or prebiotic is not going to necessarily solve GI issues or what you're sort of dealing with an athlete that's come to work with you. So we're really understanding how gut health and gut microbiota is becoming important for almost every single organ function in our body, aside from just the gut brain. The gut is our largest immune organ. It's a vital component in athlete health and becoming increasingly important to optimizing performance. It is a complex area. It's rapidly evolving. So I encourage you to, do your research, ask questions, and build your performance expertise network. And then, of course, keep learning. Our next step that we've, this is a gap we recognized, and we've built the Athlete Gut Advanced Practice course to help give practitioners the next step with, becoming more confident in working in this area. And on to our wonderful tag team RDs at Pendulum. So I thank you for listening to my section, and I'm going to pass off to Kara now. I'm going to stop sharing, and Kara will be able to fire away. And I will turn my video off so I'm not making weird faces or anything. All right.
Awesome, Dana.
Just repeating that this is going to be recorded and shared. So we originally in the invitation had this scheduled as an hour and a half. So please know that we have another section here, and if you have to jump off early, we'll be recording and sending out.
Awesome. Well, that was amazing and really a great way to set the stage. And in thinking about not just this new world that we're in of personalized medicine, I mean, looking at the athlete or the individual as themselves and what they're going through, but also with this question of, we know how beneficial exercise can be, but is it enough to counteract all these things that we know that can modulate and impact the microbiome? And it's time to really have microbiome interventions as part of, a whole body approach. So a little bit of, as far as, kind of defining what does it actually mean to have a healthy microbiome? And this is something that's really big in the research. And in fact, there was just a new review article that came out that talked exactly about this. Because when we look at a healthy microbiome, there's not this perfect metabolic profile, like you have to have this much Firmicutes to Bacteroides or this much of this. What we know are key characteristics that constitute a healthy and resilient and functioning microbiome. And so a healthy microbiome, which is necessary, as Dana mentioned, for proper digestion and nutrient absorption, utilization of all those important things that we're receiving from the diet, is truly characterized by having a lot of diversity. And Dana mentioned alpha and beta diversity. So not just a lot of bacteria. I mean, they used to say we have up to 1,000 different species. I argue that in the Western society, it's a lot lower, closer to 250 to 300 species. But we want lots of different species and strains, but more importantly, we want diversity of what's known as these keystone species and your short chain fatty acid producing species. Because even though these don't necessarily take up a huge amount of real estate, Your keystone species, and I can use this analogy with this group here, they're your star players on your sports team, where like the presence of them really drives a lot of the success. So your keystone species have a disproportionate benefit in terms of the overall health of the microbiome. They help to maintain that pH. If you have a lot of these healthy commensals and keystone species, we have less pathogens, and we're having this robust short chain fatty acid production, which we'll talk more about. And that really helps to reinforce what's known as that mucin layer or your gut barrier integrity, which is truly an integral part of having a healthy microbiome. When we have those very, strong tight junctions, well-formed tight junctions, your fence is very well put together. No, none of them are popped out. This is where we have a stable and resilient microbiome. Whereas dysbiosis, or this imbalance between your healthy bacteria to your pathogens, a dysbiotic microbiome, we see a reduced abundance of these keystone species like Akkermansia and Eosinophila. We see a reduced abundance of these short chain fatty acid producing species, your Bifidobacterium, your Clostridium deutericum, all your Lactobacillus, all these species that we know that you're probiotics essentially. And what this does is, as you start to lose diversity, we create an environment more optimal for pathogens to start to, take up residence, and that starts to break down that intestinal integrity and starts to decrease that mucin layer, where we lose the formation of those tight junctions, and we essentially end up with a dysfunctional gut barrier. And a dysfunctional gut barrier, as Dana mentioned, then allows for this infiltration or translocation of pathogens and pathogenic toxins, things like your lipopolysaccharides, LPSs, which we'll talk a little bit more about, but components that are on bacteria that are responsible for activating the immune system and responsible for a lot of the inflammation that we see not just in the gut, but beyond. So a microbiome that has this type of challenging environment that's dysbiotic can truly start to interfere with those key functions of what our microbiome is supposed to do. And so we start to lose that resiliency, and this can absolutely impact and influence athlete and recovery and a lot of the things that Dana already mentioned. So I love that you brought up that slide. We call it the exposome, all these external factors that disrupt or impact the microbiome. So I call them the microbiome disruptors, right? If we think of our microbiome as that foundation, these are like even like a foundation to your house, right? You might have the best house in the world, but if you have cracks in that foundation, how resilient is your house going to be? We can have a hurricane or earthquake and it's going to, wreak havoc on your house. So all these things, from medications like antibiotics that we know can decimate the microbiome, to travel and changes in your circadian rhythm, to of course our dietary choices, these are all things that disrupt, and none of us are immune to this, and neither is the athlete, but the athlete is definitely faced with their own unique microbiome challenges. I won't spend too much time because Dana went into this and you'll get more of this in your course, but we know that with increased intensity and duration, which elite athletes, a lot of what you are all working with, are dealing with, that this increases that intestinal injury and permeability and results in what's known as that endotoxemia. That's LPSs and bacteria getting into systemic circulation, which has now been shown to drive and really be at the root of what drives low-grade chronic inflammation. So we know that this intensity and duration decreases blood flow to the GI tract, which can impact gastric emptying, can impact transit time and absorption of our nutrients. Dana mentioned, we'll talk a little bit more about ultra processed foods. This was really big this year in the Olympic world, because there was a great article that came out that looked at Olympic athletes and the intake of ultra processed foods. So high calorie, high protein needs often require the use of energy bars. And they have studies now showing that emulsifiers will impact epithelial barrier integrity. They've even done mouse studies to show that intake of these ultra processed foods actually reduces the abundance of keystone species like Akkermansia, which we're going to, of course, talk a lot about. Frequent long-term use of corticosteroid injections. This is one that's been looked at in the research that has also been linked to changes to the microbiome to reduce mucosal integrity. So again, a breakdown in that gut barrier, a reduction or loss of those tight junctions that now opens up our immune system to pathogens and bacterial components. And so we want to think about that, especially again, in terms of formulating these plans. What are our athletes going through that we know are necessary, and how can we counteract some of that damage? But intense, prolonged exercise, we know increases our core temperature. This is a lot of the eggs that and the gastrointestinal distress, a lot of the IBS type symptoms that we see, which we now know impacts intestinal integrity and can really start to drive changes in that gut barrier, and really start to contribute to more intestinal permeability. So these are all the things that we want to think about when working with the athlete. And so I just highlight the mucosal barrier. I truly think of our mucosal barrier, which I love this image. This is a staining from a very prominent microbiome lab, Justin Sonnenberg. And it's really cool. So here we have our microbiome. This is your Firmicutes, your Bacteroidetes. This is your mucosal barrier. So in the large intestine, it's 2 cell layers thick. And this is really the only sterile part of the body. We know blood and urine have bacteria in it, but this is truly sterile because it is that barrier between what's happening in your microbiome to what's happening beneath that epithelial barrier, which is your immune system. So a breakdown in this mucosal barrier now opens up the immune system to bacteria, bacterial toxins, those LPSs, inflammatory cytokines that can now get into systemic circulation. So the health of the mucosal barrier really does rely on the presence of certain microbial species, as well as their compounds or byproducts that they produce in maintaining that integrity. We now look at increased intestinal permeability and the resulting innate immune responses, endotoxemia, as really being ground zero for most of the non-communicable diseases that are out there. And there have been studies to show that. So again, when we think about all the positive things we're doing to help maintain this from diet, is that enough to potentially counteract the exposome or all the things that we're exposed to? Because we know that microbiome imbalances can not just negatively impact performance because it may produce GI distress in the eggs and contribute to more GI symptoms, but we know the microbiome is linked to so much more beyond just the gut, from obviously the gut-brain axis that Dana talked about, and we'll talk a little bit more about that, to impaired immune function, which we know can impact our recovery, to blood sugar spikes and crashes. So our metabolic system, which is one of the key functions of our microbiome, if we have a disruptance or a dysfunction within in all these characteristics, then we're going to potentially see those metabolic disturbances occur. And of course, inflammation and more oxidative stress. So probiotics become a very important part of not only improving and obviously managing symptoms, but really necessary when it comes to modulating the microbiome and improving that overall resiliency. And what we're learning through the science and what we do at Pendulum and other companies are also doing, but we're starting to now understand the need to intimately and intricately know the microbes that you're working with. And this is when Dana was talking a lot about strain specificity. And we'll kind of talk about some of these thought starters, but why it's important to look at those weird names and numbers and the research associated, because functions change as you get down to that strain level. So I equate it to, we are all Homo sapiens, but the strain Caracidin is different than the strain Dana lists. So that is how we have to think of our probiotics now. And so here at Pendulum, we really are focusing our innovation and our strains really in tune to what we're seeing in the science, and really starting to try to delve more into what strains have this sort of outsized or oversized impact on shifting that microbial landscape and promoting these healthy characteristics of what's necessary to have a healthy microbiome, and really beyond the gut itself. And so a lot of our research has been in the metabolic space, and we've got lots of clinical research underway in looking at other body systems. But we just have this better understanding now that the microbiome is our foundation, and it's really the foundation when talking about so many chronic conditions that we face. So we're focused on leveraging microbiome science to really identify these novel and keystone strains, as well as novel ingredients that are truly impacting people, athletes, patients, whoever we're really working with on their microbiome health journey. And our founders, are really focused on how to bring these strains to market. And one thing I appreciate and love working with Pendulum is that we control the process. Like, we manufacture our own strains, and we have third-party testing, we do in-house testing, our quality control. And so we're really controlling this process to make sure that we are providing something at top quality. And so we have 5 different strains that we work through. We're going to go through a couple of them today. But we have Akkermansia muciniphila. We have these butyrate producers like Clostridium butyricum. We have Anaerobutyrycum hallei, which is actually an interesting strain in the athlete world because that, among others that Dana was talking about, can metabolize lactate. And what it does to metabolize it is to produce short chain fatty acids and other intermediates that we know impact diversity and the health of the mucosal barrier. So just a little bit about some of the science. Keystone strains, a lot of our probiotic strains are what's known as anaerobic. And anaerobic means that they really don't survive in the presence of oxygen. So it really makes the gut microbiome this optimal environment for them. And so it's through this advanced DNA sequencing that previously undiscovered anaerobic strains have now been identified. And these anaerobic strains we know have this profound impact on shifting and transforming our microbial ecosystem into a healthier and more resilient state. So these anaerobic strains that thrive in oxygen-free environments like the microbiome, they're actually not oftentimes measured, or we don't like to really measure them in what are some of the more traditional measurements when looking at probiotic techniques like the colony forming units, which is probably what we're most commonly used to seeing. So at Pendulum, we actually use something called AFU, which is known as active fluorescent units. And this is via something called flow cytometry. And it's actually a more precise method that measures all of the viable cells, including those that may not produce, but are actually still active. And we're going to talk about that because when strains die, like through pasteurization in our food, or we hear the term postbiotic, which we're going to talk more about, but dead strains do still maintain some activity. They're just not fully metabolically active. So you don't get the entire benefit of those strains. So CFU, which is just counting, I mean, some of us probably remember this from microbiology lab, but they're just counting multiplying bacteria, where AFU assesses a microorganisms or a microbiota's ability to actually survive in various conditions. And so we often, this is a myth that we often hear, is that, higher CFU counts, are better, or the more the better. Or that may sound like it's better, like, yeah, 10 billion is better than 1 million or 100 million. But the most effective dose of a probiotic really depends on the strains that are being used. Have they been studied in humans? And have they been proven to deliver positive results? So if a strain has been studied at 100 million, say AFU, taking 500 million may not be that much better. Or a strain like Akkermansia that's been studied at 100 million AFU, can you then say that, oh, this Bifidobacteria infantis or this Bifidobacterium longum at the same amount has the same qualities? No, because I am different than Dana, and this is why it's so important to intimately know and understand what our strains are doing. And so, of course, a lot of the questions we get, well, if they don't survive in the presence of oxygen, then are they alive in your capsule? And this is why capsule technology is very important, and something that we also put a lot of emphasis on, in that live bacteria is truly the gold standard when it comes to probiotic therapy, because you're getting then all of the metabolic benefits. I kind of use the analogy of like live bacteria to say our postbiotics or dead bacteria. It's like eating the whole fruit versus just consuming, say, the fruit and the juice. You're going to get some benefits, you're just not get all the benefits that we want to see. So we really focus on our capsule technology to make sure it's surviving through the gastrointestinal tract. Okay, so I'd love to see in the chat, but how many of us are familiar with Akkermansia? So please put a 1 for yes, a 2 for no. I just love to gauge this. This is our favorite strain, not just at Pendulum, but even prior to that. We always say that Akkermansia is the shining star of the microbiome. And what's important about Akkermansia is that really over the last 20 years, this exponential increase in not just microbiome science, but really science around Akkermansia and its benefits in a wide variety of chronic conditions. So Akkermansia is a keystone strain. It's a star player of the microbiome, and it's really important when it comes to gut barrier integrity, metabolic health. It lives in the mucosal layer. This is a very unique characteristic of Akkermansia, and it takes up a very small amount of real estate. So even though it's only about 1 to 4% of the microbiome, but it has that disproportionate benefit on the overall health of the microbiome. And there's been studies now to find that elite athletes actually tend to have higher relative abundance of Akkermansia compared to sedentary individuals or non-elite athletes. But we also know that the levels of Akkermansia and the levels of these keystone strains are impacted by all these exposomes and all the things that we've already discussed. So low Akkermansia has actually been associated with a variety of conditions, from obesity to gut-brain dysfunction. We know Akkermansia actually can produce tryptophan metabolites, and GABA, which we know impacts the gut-brain axis, but also impacting our immune system and our immune function and diabetes and blood sugar, but also that gut barrier dysfunction. So really important in terms of fortifying that mucin layer. So some of the benefits, what do we know about Akkermansia today? So Akkermansia is kind of has this sort of like threefold or trifecta effect to it. So Akkermansia lives within the mucin layer, and it can consume mucin. So even though we know that mucus is regenerating every 3 to 5 days, we have all these other things that are impacting the integrity of that mucosal barrier. So Akkermansia actually consumes that mucin, which stimulates our goblet cells to actually start to produce new mucin. And in doing that, it actually produces propionate, which is a precursor to butyrate. And then one of the key byproducts that Akkermansia produces is something known as AMUC1100. And AMUC1100 helps with immune homeostasis. It binds to what's known as our TLR2 receptors. And this actually helps to produce our anti-inflammatory cytokine interleukin 10, which we know is very important when it comes to immune regulation. But then the other key thing that Akkermansia does is it produces another byproduct, what's known as P9. It's a protein that specifically binds to receptors on our intestinal L cells, which actually produce GLP-1. And GLP-1 is important for obviously blood sugar management and appetite control, but GLP-1 also plays a huge role in the integrity of the gut barrier. And so Akkermansia is not only helping to fortify that mucosal barrier in producing short chain fatty acids, producing these byproducts that play a key role in microbiome function, but it's also helping to fortify our metabolic health by producing these specific compounds that specifically target GLP-1. So if we don't have Akkermansia, this is actually being considered now as a biomarker for poor intestinal integrity or poor mucosal barrier integrity. Because if we don't have Akkermansia, then we essentially don't have that microbiota there that's not only helping to create an environment that's more friendly to our, or more optimal for our keystone species, but we essentially start to see a degradation or a loss of that mucosal barrier, where now we lose those tight junctions, and this essentially drives immune activation and inflammation. Oh, whoops, I forgot I had, there we go, okay. So live Akkermansia, I kind of mentioned this, that there are other companies, there are other strains out there, and you'll see this with multiple types of strains where there'll be live versus pasteurized. What's important to understand about live bacteria is you're getting all of the metabolic benefits. So live Akkermansia, you're getting the mucin consumption, you're getting the ability of this AMUC1100 production and P9 and short chain fatty acid production. Whereas when you're supplementing with a postbiotic or a dead strain, you're only getting a very small or targeted benefit. And so pasteurized Akkermansia cannot consume mucin, and it can't interact with the diet, especially things like our prebiotics and our polyphenols, to actually help to maintain the levels of Akkermansia in the gut. So dead is just coming in, it's like, again, it's like drinking juice. You're just getting one specific action. Whereas if we're trying to really shift and increase resiliency in the gut, we have to try to maintain these levels of beneficial bacteria. And with diet, and by using these live strains, then you're going to have a better chance of having those levels actually repopulate itself. So this is a study that looked at Akkermansia specifically in response to exercise, and truly found that Akkermansia increases in response to exercise. And so athletes in this study harbored more Akkermansia than sedentary controls. And so again, looking at the benefits of Akkermansia, in improving lipid oxidation, and there have been other studies that look at that because of its ability to produce short chain fatty acids, as well as its ability to reduce bacterial translocation, specifically of those LPSs, which we know drive changes to our metabolic health. And it really comes down to that fortification of the gut barrier. So this was a study that looked at Akkermansia and elite athletes and what types of bacteria are more prominent or more often found in the elite athlete. And again, found that Akkermansia was positively associated with exercise, and it correlated to better metabolic profiles, which we know, and we'll talk about in a moment, that blood sugar regularity is a really important aspect of performance. And then also, again, just really showing a lot of the benefits that we already know, that Akkermansia enhances the composition of the gut microbiota. We know it reduces inflammation through the production of AMUC1100, through the production of fortifying the gut barrier, through short chain fatty acid production. And that has an impact on overall performance and recovery in athletes because it's improving those functions of the microbiome that we know are necessary. So one of the next strains that we manufacture, this strain called Clostridium butyricum, and people will hear that word Clostridium and just instantly, think of C. diff. And no, we have lots of different Clostridium, and many of them actually are commensals. But Clostridium butyricum is a very prominent butyrate producer. It's really one of the most prominent butyrate producing strains within the microbiome. And this has been one that's been looked at in its ability to help manage GI symptoms. Excuse me. So it's known for its ability to produce butyrate being a very important short chain fatty acid. It's the primary fuel for our colonocytes. We know butyrate impacts just about every aspect of health from gut brain because it can cross the blood brain barriers, so it can impact neuroinflammation, to, of course, our metabolic health. Butyrate can stimulate our intestinal L cells to produce GLP-1. And research has shown, and we've found that supplementation with Clostridium butyricum is associated with improved gastrointestinal symptoms and improving that immune modulation and immune response. And so really investigated for its ability to help with a lot of the functional GI distress that we see, or symptoms like IBS, which is really common in our athletes that are suffering from eggs. So short chain fatty acids have a very prominent place and role when it comes to sports performance. That we know that they help with improving glycogen replenishment, glucose uptake, lipid metabolism, muscle function. Short chain fatty acids activate different receptors in the gut that all can play a key role in impacting exercise performance and recovery. And remember, as we lose diversity, as we start to intense exercise and travel, the exposome, antibiotics, steroid injections, and increasing core temperature, all these things that we know are impacting that mucosal barrier is impacting the diversity, which is now impacting how much of these short chain fatty acid producing bacteria are present in the gut. Clostridium butyricum, because of its prominent butyrate production, actually helps to strengthen the gut barrier. It can help with the expression of our tight junction protein, so really helping to fortify that fence and that gut barrier, which in turn helps to prevent bacterial translocation of those LPSs, which we know is responsible for a lot of the inflammation, not just in the gut, but beyond. This was a specific study that looked at Clostridium butyricum and its effect on stool frequency, and showing that it actually helps to improve that in people who were suffering from IBS-D. So again, really showing its role in IBS and IBS symptom management. So what is the role of glucose control? We know this is really important because glucose spikes have been associated with increased fat storage and cravings, decreased motivation, changes in our sleep habits, changes in obviously our appetite. And so if we can lower glucose spikes in the athlete, we can actually help to impact and improve athletic performance because we can help with improving and sustaining energy, improving body composition as well as lean body mass, right? Decreasing hunger and cravings. I think that's really important. And again, it goes back to why certain foods get chosen is we have to sustain that energy level. So we know that blood sugar plays a huge role in that, especially in terms of the production, in regards to that production of GLP-1, which we know plays a key role in appetite and hunger. And of course, can improve our mood, focus, motivation. So this was a study, this was a trial that we did on one of our products known as Pendulum Glucose Control. This contains all 5 of our strains that I had shown earlier, including Akkermansia. And we looked at a couple different outcomes, but ultimately what we found and what we really wanted to assess was, what is this doing to our glucose and our blood sugar regulation? And this was looking at type 2 diabetes patients. And so we found that after 12 weeks of supplementing with Pendulum Glucose Control, no other changes, and really just looking at what the probiotic is doing, that we lowered glucose spikes by 33%. We had a change in A1C by 0.6%, which is huge because outside of the athlete world, I mean, this is something that can take someone from being diabetic to pre-diabetic to not diabetic. And so really clinically meaningful. And we also found that obviously this was very well tolerated and safe in our study participants. So again, going back to strain specificity in research, we can't just say that all Akkermansia muciniphila functions the same way. Although we know Akkermansia, that a huge part of it, but this is why research and putting focus and attention to doing research on finished products on the strains is so important because we actually see the clinical impact that it's doing in each person and body. So that's a little bit about our strains. I'm going to just kind of shift a little bit more into kind of overall microbiome um, testing and studies and what we want to consider when working with the athletes. And so one of the biggest questions that's often asked is, how do we measure the microbiome? Like, what's the best way? You know, there's all these different tests out there, and is it enough to just take into account lifestyle and symptoms? And I don't have an answer for you because there's, I mean, I know what I do in practice, and I think there's an argument for both sides. But stool testing and microbiome assays are really becoming more prominent in the clinical space. And just to give an overview, there's a lot of different varying technologies. And this is important because, like anything, your technology comes with a level of specificity and sensitivity. So just to give a little bit of a background, and I know we're getting close on time, so I'm going to kind of power through. 16S, this is kind of the old school technology. This is like this was created 40 years ago, like really hasn't changed much. And this gives a good indication of really kind of that genus level. It's not as sensitive or specific beyond the species and strain. So you're really only getting more of like a taxonomic view of who is in the microbiome. So who's there, right? Which we can make a lot of inferences, right? Because if you don't have keystone species, if you don't have those commensals, if you've got more pathogens, again, thinking about the healthy characteristics, then we know that we're dealing with someone who probably has a dysfunctional gut barrier because we know those are characteristics that lend itself to breaking down the mucosal barrier. qPCR is basically oftentimes coupled with 16S because you're basically taking a snapshot, a couple genes, and then amplifying it. So that's why it's really not as accurate beyond that species strain level. So it's not as good at identifying those strains, meaning me or you, which is important because when you look at different species, like for example, Bacteroides fragilis, which you guys might not know, but this is a species that has different strains. One can be pathogenic and one can be a keystone species. So it's really important that we start to challenge some of the accuracy of what we're getting. And then we have shotgun metagenomic sequencing, or you might hear it as whole genome sequencing. What's cool about whole genome sequencing is you sequence the whole genome. So you not only can see who is in the microbiome, but you also get the functional capabilities. So how much of this microbial sample, how much butyrate is being produced, not necessarily what butyrate producers do you have there, but what's the functional capability? So Dana talked about we have certain species that we know can synthesize vitamins. K2, for example, is solely made in the microbiome unless you're eating like a ton of natto, which maybe you guys are, but I'm not. I love fermented foods, but it's pretty funky. But we have species that can do it. So if we see through vitamin biosynthesis that we're not synthesizing those endogenous vitamins, again, we have to look back at, well, who are we missing? And then we have metatranscriptomic. That's a mouthful. This is mRNA. mRNA technology tends to be the most unstable. So it's really only reporting what's active at the time of that sample collection. And so just keep in mind, you know, with stool testing, it's providing a snapshot, right? It's giving you a baseline into the current state of your athletes or your patients or your clients' microbiome. And it can be a nice tool to help you create more personalized, individualized, and make more informed decisions on these personalized interventions and the steps to take and kind of create a more stepwise program to figuring out how to really increase that resiliency and improve the foundation, which is our microbiome. So of course, there's some pros and cons, right? Like in conjunction with your symptoms, lifestyle, diet, everything, it can really be part of a comprehensive plan, especially I think Dana mentioned, like your athlete that's traveling like overseas and back, and all of a sudden is finding that they're not sleeping as well. Like that might be a really nice time to get a snapshot of like, hey, let's look at your microbiome and figure out how to personalize your plan for you. You know, and again, it gives you changes in the individual over time. There are a lot of cons. Again, just like anything, technology is evolving. Again, we want to really challenge companies in looking at what's the research you're putting behind your stool testing and your product. You know, what are we looking to get out of it? So again, I'll kind of go through these just because I don't want to lose time. But your microbiome is an ecosystem and it's changing and it's evolving. We know diet is really one of the biggest modulators of the microbiome. And so can your microbiome change within a 24-hour period? Yes, but we want to get more of a long-term understanding. So again, I always tell people when they're doing microbiome testing, or if I look at one, it's a snapshot. Yeah, your microbiome tomorrow might look different, but it's not going to be that drastically different unless you're doing something for a longer period of time where you're truly modulating and um, shifting into a more stable state. Um, just going to plug this because I think this is so cool too. This is one of the studies we have underway with a new technology coming out of Jack Gilbert's lab. He's really big in the micro. If anyone saw Hack Your Health on Netflix, he was featured on there. And so this is a partnership that we're doing with BiomeSense. It's so cool. It's like the CGM of stool testing. So basically, like you wipe, you put it in, and you're getting a continuous a continuous sample readout. So you're actually able to see all these important. I mean, think about CGMs and how that really revolutionized how we look at blood sugar and blood sugar changes, not just in someone who's diabetic, but in a healthy individual, like even athletes, to see, well, when are you getting these spikes and does that correlate with symptoms? Kind of the same thing here. So we're really excited. We should be hopefully getting some of that data back really soon. Okay, so really quick, we're rooted in science. It's important, right? Not just to educate on products, technology, but really, we focus on educating providers like you because the microbiome, I didn't learn about it in school. Like I came into it because I worked in gastroenterology for 10 years and was like, I always used to tell my docs, like, hey, you guys know the GI tract, but like I work beneath that. I'm there to manipulate the microbes. And I think that it's just this ever evolving world. And really the last 10, 20 years has pushed us into understanding the microbiome. So prebiotics, this is your food. This is your fertilizer for growth. Your probiotics are your live bacteria. Postbiotics are either the outputs or dead bacteria because they still have some benefits. And then symbiotics is the combination. So when we look at prebiotics, think of this as like your FODMAPs. And Dana mentioned she's done so much work with FODMAPs, and especially those athletes that may be dealing with eggs and you're maybe utilizing a FODMAP diet to manage symptoms. This actually has profound impact on the microbiome. And there have been studies, Dana mentioned this, that even after 4 weeks of FODMAP, that we see a drastic decrease in microbial diversity. So prebiotics are essential. They're very much a part of a microbiome diet. And of course, we may have to adjust it depending on what phase or what's going on. But after we really start to recondition the microbiome, these need to be added in or they really need to be emphasized in the diet. Probiotics, right? These are live microorganisms. These are all the kind of official definitions based on ISAP. These are some of your top probiotic foods. And like Dana mentioned, can we get everything we need from just consuming probiotic rich foods? Absolutely not. Are they part of a microbiome friendly diet? Absolutely, because you are going to get lactobacillus strains. There are some bifido strains that you can get. Are you getting all of the metabolic benefits of those strains? Probably not. So when you look at viability, is there going to be a ton of viability? Probably not, because things go through pasteurization. But you are going to still get beneficial compounds. But the other key factor is you cannot get all of these keystone and essential key health promoting strains from food. Akkermansia is not found in food. Clostridium butyricum is not found in food. A lot of these anaerobic strains and these next generation strains that are being discovered are not ones that are found in food. And why are they important? It's because they're going missing. Those levels in abundance is decreasing, and we're seeing the effects of it in terms of the gut barrier and the inflammation and all these other chronic conditions that we're faced with. And so postbiotics, of course, are preparation of inanimate microorganisms and or their components. So you may hear of people taking butyrate, which in my mind has limitations because you're not actually modulating the microbiome, but you are getting the benefits of butyrate. But postbiotics are everything from your short chain fatty acids to proteins to certain nutrients, as well as enzymes, and then dead bacteria, right? Because they have key compounds, key byproducts that they're producing that impact these areas. So obviously, like, how do we support the athlete microbiome, right? And diet is a really key factor in this. And I don't think we can have a healthy microbiome without addressing the diet because we know it's pretty much one of the biggest modulators. And one thing, we want to keep in mind is that, ongoing disruptances, that we know our diet can do, things like restrictive diets. I worked in GI. I've had patients on such restrictive diets, and we saw worse outcomes because of how restrictive diets there are. So again, these are things that we have to think about when creating our plans. So ultra processed foods, again, I kind of talked a little bit about this, but this has now been linked to decreased epithelial barrier integrity. So again, that ground zero of what's driving dysfunction to our metabolic system, dysfunction to our gastrointestinal system. And there have been studies to show that this can even deplete things like Akkermansia. We know that fiber and prebiotics, right, which are not digested by humans, they're fermented by our microbiota, right, the food for them, that this obviously has a much powerful impact on the gut microbiota. And we know that the typical standard American diet is obviously low in prebiotics, it's high in fat, high in sugar. And so these are, of course, things that we need to keep in mind when working with the athlete. Polyphenols are another component to a healthy microbiome. These are found in our plant-based foods, and these not only help to increase diversity like our prebiotics, but they have profound antioxidant capacity. They actually help to create an environment that's less friendly to our harmful bacteria, and so really helping to push those bacteria away and really preventing them from thriving and surviving. So what is a microbiome focused diet? Well, of course, it's diverse, it's organic if possible. We really look to try to minimize those preservatives. There's been numerous studies done now on glyphosate and a lot of the chemicals being used and the impact that it has on the microbiome. We want to really look to those functional fibers and really have, again, a diverse range of protein and fats. And this is why diet's really important, because there's not a one size fits all model, and someone's diet may need to change throughout what they're dealing with. Again, you might have to do a short-term course of FODMAP, but it needs to be short-term. We have to take our clients and our patients through that very carefully to not have then negative impacts on the microbiome. So what to do if your athlete's low in Akkermansia? Well, we can, of course, supplement with Akkermansia so you start to get the benefits right away. We want to work with the diet. We want to work with improving the quality of the diet, all the things we just talked about. Even adding in polyphenols, adding in prebiotics just amplifies things, because you're actually giving then your body a therapeutic dose in really being able to then nurture the microbiome. So finally, I just want to leave you all with just some thought starters, right? Like the question is how do we know if it's the right probiotic? How do we know if it's a good probiotic? How do I choose a probiotic? It's a question we get all the time, right? So has the effectiveness been demonstrated through studies, right? And I really emphasize the studies on your final product, because you can't say that even though we've done our studies on our strains, that someone else is going to have the same benefits if they're using a different strain. So we really want to, again, intimately and intricately understand our microbes. Does your probiotic address the underlying causes of health issues? To me, primarily, like, are we actually improving those key characteristics of what constitutes a healthy microbiome? We increasing the diversity of these strains that really have a profound impact on the overall health? Are we improving the gut barrier, which we know is, again, ground zero for so many of the chronic conditions we're faced with? Or is it primarily focused on symptom management, which is okay? This is why we have personalized and individualized medicine. Right? How does your probiotic support overall human health? How does it protect your body from threats? So we want to see is the probiotic actually, like we showed in the glucose controls, we actually reduced blood sugar spikes despite changes in diet. And what ongoing clinical research is the company invested in? Because we all understand the importance of research here. And finally, we have a variety of products to choose from. We're always happy to answer your questions. We have different strains and combinations to help find what probiotic is best for your patient. So I really appreciate the time, and I know we are right up to the end. So lots of information, but appreciate it.
Awesome. Thank you
Hey
so
guys,
much,
yeah.
Sarah.
And I appreciate that we went right to right to the end. No offense, both you gals like to go, so we already anticipated this. We'll go through some of the questions here. Catherine Quintero, I want you to know we got what you're saying. It's all good. We'll have a look and we'll circle back with Kara about her slides. So
Bye.
oh, your slides, sorry. So yeah, we'll circle back with the slides and making sure that they're representative of the right paper. So we've had definitely a few people asking about access to slides and references. We definitely will be putting together a reference list for y'all. Because of just different things with this course being posted like open to the public on our website. Generally, we just post the presentation only on the free web workshop access of our website. If you're interested in taking our athlete gut course, we'll be able to provide the deck kind of within the course. And it just has to do with things being accessed by the public or kind of through a private platform, but we'll definitely get a reference list together for you. There's a few questions here. And what I will say is if you're feeling overwhelmed and feeling like, oh my gosh, I don't know enough about this space, good. That Jonko thing, like good when something's like This should be an area where you're feeling a little uncomfortable. I'm feeling uncomfortable. That's good. That means it's an area for learning. And I would encourage you to even go back and re-listen to this lecture again, because that's what I'm going to be doing as well. There's just so much good information, and just taking a step back and kind of making notes and trying to piece it all together. So we'll just pull up a few great questions here from Brianna Williams. Do you recommend checking blood biomarkers such as LPS or zonulin? Thank you. Does anyone want to answer that?
Yeah, I mean, I'm
Sarah,
happy to
take that
jump in. And then, so, again, this is kind of the world of testing. There are a lot of opportunities to look at, like LPS, I mentioned, right? Lipopolysaccharide. These are components on gram-negative bacteria that can be responsible for immune activation, inflammation when there's a dysfunctional gut barrier. You can look at it different ways. So in whole genome sequencing, you can look at proteobacteria. Proteobacteria is the phyla that contains your most pathogenic LPS-containing bacteria. There are tests that are looking at things like hexa-LPS, looking at other markers of inflammation. Again, is there changes in blood sugar? Are you seeing high LPS systemically is essentially like low grade sepsis. So there are providers that will do like baseline cytokine inflammatory profile. They'll have someone go out, eat a really high fat meal, saturated fat, because that actually kills proteobacteria, and then have them come back 4 to 5 hours later and see if there's a rise in insulin, see if there's a rise in interleukin 6, see if there's a rise in interleukin 1 beta. That's another way. But again, you can also look at some of those gut barrier markers. You can look at proteobacteria, what types of pathogens, how much gram-negative bacteria is there. Zonulin, I have my opinions. Zonulin it's got a short half-life, right? So is it a good marker for intestinal permeability? Some people might say yes and use it. I think you just have to look at the bigger picture. Do they not have akkermansia and zonulin's normal? To me, that would be a sign of poor intestinal barrier integrity. Do they have a lot of pathogens? What's their diversity? Do they have low alpha, low beta? Like these are all potential indicators for gut barrier dysfunction and intestinal permeability.
Okay, and then Chris had a great question, and he said he has clients who have dysbiosis and show elevated levels of akkermansia. If you see that, from a stool test, like, do you recommend taking it in this case, or like, how do you address if you see that in a stool test?
Great question, and it's actually one we get a lot. And again, this is some of the limitations to stool testing because you are getting a snapshot. So a lot of the studies that have looked at high akkermansia in relation to poor outcomes, they're not causative, they're correlative. And one of the things, and really the leading theory, is that if there's inflammation, which we know dysbiosis does, right? Dysbiosis creates a more inflammatory environment, then there potentially is this upregulation in mucus. We see this in ulcerative colitis. We see this in a lot of GI disorders and dysfunctions. Well, you're going to actually be providing more of that mucin for akkermansia. So it's almost like a false elevation. So probably what I would do if I see high akkermansia is, again, I'd look at the rest of the test. Are there other signs of poor intestinal barrier integrity? Are there other signs of GI dysfunction? Like what else is going on? Maybe we start with polyphenols. Maybe we start with prebiotics to help nurture the environment. And then I would actually look at, depending on other gut barrier signs or other signs of dysfunctional gut, would actually add akkermansia. I'm not, so far in the research, we're not concerned. This is something we're actually studying at Pendulum, and we have a few clinical trials underway in these exact questions of what does it mean when it's high? Because again, the science and the research is really not causative at this point.
Yeah, and I think just from somebody who practices in a really basic environment, I say that just because I have pro athletes that don't know what any of these things mean. It's important for us to look at. Yeah, sometimes also just the way that our athletes can kind of get dragged down a road of maybe thinking that a stool test is going to give them all the answers. And it's kind of, we always want to say 1 + 1, right? So I got this test, this is a result, I fix it, the end, and
Yeah,
so I think what's
look at all.
important for us to understand is even though that's like the fantasy of practice, it's definitely not the reality, and definitely not the reality of our microbiome. That's for sure. Is there anybody else with questions? Some of the other questions were just related to being able to access specific references. I really appreciate you guys hanging on here till the very end. We had a lot of people retained and stayed along for the whole ride, so that's great. And then just the slide that's on there right now, it just reviews our Athlete's Gut Advanced Practice course. It's on demand. It's live, available on our website now, and those are the modules that we will have included as part of the course. And some people texted me separately asking about the cost of the course. It's pretty affordable. It's $188, so under $200, and basically you have access to world leading lectures from Monash University, which to me is a pretty is a pretty good deal. And then this sponsored lecture will be module 7 as part of the on-demand kind of inside access to the course. So awesome deal here, guys. There's a question about an affiliate program or way for athletes to purchase directly. Did you want to maybe just answer that?
Absolutely. And I think Elena put in the chat box here. So access to our wholesale pricing and ways to get Pendulum for your patients. We take you through that. We have someone who can, our account manager, who we're happy to get you set up with. So I would just say, let's shoot us an email and let's get you connected and find out the best process for you to get Pendulum for your patients.
Awesome. Well, thanks, guys.
Yeah, thank you.
If there isn't anything else, we will be, someone was saying the course is not showing. You should be able to just go on to performancenutritionpros.com and then click the link that says learn more. And then there's learn more for the Athletes Guide Advanced Practice course. And then it'll take you to a little tile there where you can view details. So we appreciate your time, and thank you everybody for hanging on. We'll record and distribute as well as a reference list. So thank you everybody, and have a great day. Thanks, presenters.
Thank you.
Thank you.